Hello everyone, and thank you for coming to our session about neural networks. I'm very glad to see that there are so many people interested actually about neural networks. My name is Zoran Ševarac, and I come from the University of Belgrade. I work for the Artificial Intelligence Lab, and together with me is Gercan Vilenga. He works for Oracle. He's a principal NetBeans director, right? So just before we start, can you please give me some feedback about what are your previous experience, what is your background? So please raise your hand, all of you who have been using neural networks with at all. Okay, great. And how many of you are there who haven't been using neural networks but have some theoretical background about neural networks? Okay, great. So then I will make this introductory story very brief, just to know what we are talking about and get to the demos and the Neuroph framework and show some real good examples. So neural networks are a machine learning technique that is able to learn from the data and create a sort of input-output mapping. So the idea is to take some data set and to define what outputs do we want to get for that data set, and the neural network provided the data can learn and provide that mapping. When we say it like this, that means that we don't need to program at all, right? We just use neural network and create some with some kind of a magic. It learns what we need to have to create the functionality that we need, but it's not that way at all. It requires a lot of experimenting, tweaking, and programming to get them work right. So the basic idea behind the neural networks are that they are model, very rough model of what we know about the brain, how the brain works, and we have a set of neurons that are interconnected with neural connections, and while they interact, they modify the connections, right? And that's how they learn. So the key for learning is modification of these connections. What's very interesting about them is that actually their main feature is that learning capability, and the thing that they are able to generalize from the data they have learned. That means that they can successfully solve problems also with the data they haven't been learning, so with data they haven't seen. And very nice thing also is that they are resistant for noisy and incomplete data. That makes them very suitable for practical applications, which are very difficult or impossible to solve any other way. The typical problems that neural networks are used include problems like classification. That's one of the most typical applications. Then recognition problems, which include image, face, fingerprint, sound recognition, or any kind of signal processing and recognition. Then approximation. So if we have some amount of data about some system that we don't know how it works, but we have data that describes its behavior, which can be represented as input-output pairs, we can use that data to train the network and to get the approximation of the system behavior, even if we don't know anything about it. Also, one typical application is prediction. So very popular is time series prediction, which can be used for stock market prediction, weather prediction, network traffic prediction, application load prediction, and all sorts of kind of things. And at last, but this is not an extensive list of applications, but the one are the most, let me say, popular is the optimization problem. So when we have many parameters that control the behavior of the system, and it's very hard to tweak them by any meaningful way because we don't know much or enough about the system, when we can use neural network to model the system and figure out the optimal parameters for its operation. So how do you use all of this in practice? How do you use this for Java application? Well, there are several frameworks for neural network, and two of the most popular at the moment are Neuroph and Ankle. Today we will talk about Neuroph framework, which is the project that was originally developed at the Artificial Intelligence Lab at the University of Belgrade, and it is a project that I started as a student and then continued to develop my career. So Neuroph is an open source Java framework for creating neural networks that can be easily used in Java applications. So we have Java library, right? And we have. Can you do something with the sound? I don't know. It's like it's fine. It's feedback. It's feedback, right? Feedback.
Move the mic. Just point it closer to you, and then she can probably turn it down.
Like this. Okay. The Neuroph framework provides Java library, which is a simple small jar file, and also development environment, which is based on NetBeans platform for creating these neural networks. The development environment is is integrated with NetBeans IDE, so it's very simple to create a neural network in Neuroph Studio, and then use that neural network in your Java application. When you create neural network, you can save it as it's saved as a serialized Java object, so it's very easy to load that network into your plain Java program and use very simple and convenient API to make the network do what it is intended for. So one of the very important features is that Neuroph is very easy to extend and customize due to its design. Its design is very clear and logical, object-oriented, and it has very clear extension points, and it has a plugin system. So that plugin systems provide separation of the neural network design and the specific application. So if you want image recognition, you create plugin for image recognition. If you want stock market prediction, you create a plugin for stock market prediction, and so on. So the basic classes that are used within framework are they stay clean from application-specific code. So out of the box, Neuroph provides some examples, like I already said, for image recognition, OCR, optical character recognition, and time series prediction. These features are not production ready, I must say. They are very basic ones, but you get the idea how to use them and create stuff on your own. Current applications of the Neuroph framework include education. It's been used at our university for teaching neural networks, and it's very nice because it's clear, thanks to its clear design, students can easily, with the basic Java knowledge, get the idea what is going on, and they are ready to use it, also using that application Neuroph Studio. And you'll see later, applications include also research applications. There are many applications for voice recognition, for estimation of effort in software testing, and so on. And of course, there are real-world applications that are using Neuroph for sure. At the moment, we have about 600 of downloads per week, which is a pretty good number for this specific type of framework. The whole framework and documentation is available on the framework site, which is neuroph.sourceforge.net. So I will just summarize a few most important features of the Neuroph framework. Is that and which are the main reason why it have became so popular. It is at first point clear design. It is easy to follow because usually when you start doing your own stuff, you figure out that you want some things done different, and you want to change and you want to experiment. And if you are not able to tweak code and behavior, which is a common requirement, then you are not able to use a framework efficiently, which is the case for many other frameworks. For Anchor, for example, it is based on, it has array-based implementation, and it is very hard to figure out what is going on in all the for loops and arrays, while in Neuroph you have a clear object design. Then you have very nice documentation and support. We have forum and ticketing system, and our community do its best to answer all the questions. Then is the rich user interface, which is based on NetBeans platform. It's called Neuroph Studio, and it was the big step for the Neuroph when it's ported to NetBeans platform, and that's why is Gerchen also today with us to tell you, to give you ideas about your project, so what it can do. I will show you the download statistics, and then it will be clear to you what I'm talking about. And last, maybe the most important, is that it is very easy to use in other applications. In other words, in your own application. So that was the primary idea, to bring the neural network power into the hands of regular Java developers who maybe are not familiar with neural networks, and they don't have to know the details of the algorithms. They just should be able, that's a long-term vision, which we are getting close to, using a drag and drop interface to put the network for image recognition, to put the prediction network in their application and drop it and use it as a Java bin, for example. So, just to show you some project statistics, since the version 2.1, you see that we had average 30 downloads per day, and at the moment we have, with version 2.5, we had 90, 80, and then 65. We had the actual version 2.6, but since we have not released the new version, it is not listed here. So what I would like to show you here is that data for the version 2.5, it is outlined with blue, and you can see that the release lifetime of 2.4 was 240 days. This is because the development of 2.5 was take long time, and that's when we were porting to NetBeans platform. But if you take a look at average daily downloads, you can see that we have jumped from 36 to 90 downloads per day, which is a really big thing for our framework, because suddenly it became very easy to use and intuitive to users, and it could do more powerful stuff. So this is the screenshot, how the Neuroph Studio application looks like. And this is a wizard. It is wizard based, so you can say new neural network, next, and set the parameters and create new neural network. So the reasons why we decided to port to NetBeans platform is that we realized from the beginning that people, well, actually I needed some nice user interface that would be easy to create neural networks and to play with them. And at the moment there were no such a tool that would satisfy my preferences. So I started working on it, and I think we have developed 3 different versions of the user interface, and at some point each of them started to become very buggy, and it took a lot of effort, took a lot of time to add new features. And then we find out about NetBeans platform, and then we decided to move it and get that project system and get that navigator and get that visual tool. You have a palette and just drop neural networks components to create neural networks. But when we ported, then we realized that there is much more to gain from porting, like reusing lots of stuff that there is already created on NetBeans platform and integrated with existing things, like that real-time graph drawing that you are going to see later. And there is a great opportunity to integrate with other NetBeans platform applications, like, for example, NetBeans IDE itself. So we have one application. We can do the neural network development and Java development. So we don't have to jump from the neural network application to develop the Java application, some IDE. It's much easier to work with. And many other things like update system, which is not implemented yet, but is one of the first on our to-do list. Easier design, which improved design, which made application easier to extend and maintain with a system of plugins, because this platform provides that plugin system. And in general, we have improved overall quality and ensured some future development of the application. So here is a little list about who is using Neuroph. Well, here are some links. You can see more at the Neuroph site at the application link. Here, this is GeoGebra. It is a mathematics software for teaching. It uses Neuroph OCR support. Then, thanks to Data Raw, there is a set of engineering application that makes Neuroph available from the Amazon cloud. Then recently a group at our university have created a Neuroph plugin for data miner, which is a well-known data mining application. And the results, some tests showed that Neuroph provided better performance than the existing rapid miner neural networks about. Oh, well, just a second, we are about to lose the power, so. Sorry. Sure. Then there are two research applications, two research papers you can find. It's a test effort estimation using neural network, published in Journal of Software Engineering and Application, and a framework for an integrated voice environment, which is published on a conference. Then there are many game applications. One of them is Tic-Tac-Toe with the Neural networks, which is available also on SourceForge. So these are just some of them. On this link you have more, and I'm sure that there are many of them. Or just I'm not aware of it. So if you create something interesting, please let me know so I can list you there. So I'm going to show you a few demos to get the idea how it works. Here, first I will show you a sample, which I'm showing to my students usually, to give them an idea what it's all about with samples. Now we have this nice research system. One new sample, this classification sample, which is probably very familiar to the people who already worked with knowledge, but I'll show you. It's very nice to see. So let's create some classification problem by clicking on this let's say data space. We have two features, and we have red dots and blue dots, which represents features of some object that we can transform into the numerical form. And now we want to make the network to learn this problem. So in this sample, we can set the parameters, like say a number of neurons, let's say 8 hidden neurons. Number of input neurons is known. We have 2 input neurons since we have 2 dimensions. And the number of output neurons is 1, and it distinguishes between 2 classes, red and blue. And we just hit this, we can set these parameters for learning, let's say learn grade 0.2, that's my favorite one, and momentum 0.7. Yeah, not really. For the most application it works, it's amazing. And now when we put it to train, you see what we see?
These are real-time charts on Visual VM.
Yeah, for Visual VM. This component here we took that component from the visual VM. It is the only way you can draw real-time charts, as far as I know, in Java, right? Because we have created our own component, but it is very hard when you want a real-time charting, because you have to scroll at some point, and it was very buggy and blinking the way when we were doing. So you see, this is how it looks when the visualization of the problem, how the neural network will learn the problem. So in order to make things a little bit difficult for this poor network, right, we're going to do things like this and show you how it works, right? Let's say we got some more data and we say, come on, run this. And here we can observe what it is going on, how it is adjusting its, right? And here is the network. We can also take a look at the graph. But as you can see, it has issues to learn this, right? Because it doesn't have, but it's not bad at all. You see, there are some of them which are not covered, but it's good. And you see, you cannot do things like this with some algorithm, you know, that you are going to code. Well, maybe in some cases you can, but when you have new data coming during the system operation and you want to adapt the behavior of your application to that new data, you want to create adaptive controller, then you can use neural network. So we can play with this, you know, we can fool with network, add some things more. And let's make it really difficult to put some things here. Well, no, it's very difficult. But so keep in mind that this is a network with only 8 neurons, right? Let's try to put more neurons. Let's try to put 12 neurons and put another layer of neurons, let's say 8. We put two layers of neurons and then hit. Let's see what it is going to do. It's going to hit. It's for some time it will try. While it's trying, yeah. So it's just the thing of trying different parameters, right? Setting the right architecture, the right number of neurons. And what's nice with this, I think this is the network, right? Yes, it's done. And we can take a look at the network. You see here, right? These are the neurons. For example, you can see this is the first version of the visualization of that network. But okay, I can shut down some things like this. And we can observe the network error. Look like how smooth the scrolling is, and nothing is flickering in. Yeah. See, it's a very difficult problem for network to learn, and it takes time. Sometimes training may take 4 hours. Okay, I can stop it now to show you this part of application. So what's nice, maybe you want to try different number of neurons to increase, to create less, and then you can go to this design view of neural network. So this is the visual editor created with the visual library from the NetBeans platform. As you can see, this is the network architecture. So we can see we have a LED here. We can drag and drop more neurons here. And we can connect them to this, right? Put 2 more neurons. Or we can remove some neurons from this layer, right? Or we can add a new layer to network and add more neurons, right? And easily connect neurons. So you can create a custom architecture, you know? And it's something what I always, it's a kind of a brain builder, right? Something everyone needs. And here is the training sets, right? You can take a look how the training data looks like. The dots that we were clicking on the screen, this is the that data. So let's see how we are with time. Okay, I will. You can download the software and play with these examples, and you have a help system. Okay, and now this was just a sample to show you how it works. Now we are going to do some like real world application like image recognition. So we create. So the task is the following. Assume that right, it's here. We have the set of the following images, right? A Duke, a Gerchan, Java logo, JavaOne logo, NetBeans Dream Team, Oracle, and Zoran. And we want to create neural network that will distinguish, that will recognize these images. So it's very simple. We create a new Neuroph project, like in the regulation, right? And then we say create new image recognition network. And then this is a wizard. We say, it says select image that you want to recognize. So we go to a folder and just select the folder with images, and here we can see all of these images that should be recognized, right? Then we hit next, and on the next screen we are asked to select images that we don't want to be recognized. So this is a kind of a trick to help the network to learn the better, easier. We use all blue, all green, and all red, because the image information which is extracted is converted to RGB data and normalized. So if you want to avoid white space background, whatever is in background, we don't want the network to learn the background. We want the network to ignore the background, which is in this case the white. And now we create training set label, say image data, and image resolution sampling, which we use 20 by 10. So we are going to scale these images in order to create smaller network and do faster learning, because this network will have a lot of new input neurons. For every pixel of the network, we have 3 new neurons for every component of the color. So we have 20 times 10, it's 200, and times 3, it's 600 neurons. Input neurons. So we say we use ImageNet, and we, let's say, we use 12 neurons, hidden neurons, and say next. And here we get a neural network and the training data. So you see, you have a wizard, you provide your problem, right, images you want to learn, and the application creates the network that you need. We say train a network, right? Select this training set, open the network, hit the train button. Then we can set the training parameters. Again, my favorite ones, 0.0 and 0.7. Try it, it really works, it's a magic number. And here is the network learning graph. Okay, it is very fast, just 100, nearly 200 iterations, it has not. But now, let's see how it works. Here we have a test window. We can select images, right? And let's say we select Gerchan, right? So the probability that this image is Gerchan is 0.9, while the all other, you see, 0.01, 0.0. So the neuron with the highest activation corresponds to the image that it is recognized. Let's say select Duke. So this is Duke. We have 0.9 for Duke and less for all others. So let's say if you want to recognize Oracle, this is Oracle 0.8 and everything else is nearly 0, you know. Because neural networks are not very precise, they are very rough approximators, but they give you an idea of what's going on. So you can, usually you use neural network in combination with some other approach, not just neural network. And it can help deal with the parts that are difficult to do some other way. So,
can you show how you include these results in an actual application?
I can show you. So carefully. Yeah.
You're testing on the test set looks like almost the same set as what you fed it in.
Yeah.
What if you disturb the input set a little bit? What would happen?
Well, then you have to prepare a little bit disturbed training set. For example, include some disturbed images, disturbed variation of images for each image that you want to recognize.
So, can that be part of your...
Well, I have not prepared, I don't have, but it's a good idea. We can try and publish it on the website. Maybe you could try and contribute to Neuroph with it. So these are a few lines of code that shows how to use this. So when we hit save, okay. So when we have created that, we hit save, and it is saved this here in the Neuroph project. Okay, this is that neural network, and in order to load that network in your application, you use this static load method saying neural network.load, and you specify the file name that you train network. Then you get the image recognition plugin from that network with a simple get plugin method, and then you call recognize image method from that plugin. So you have only 3 lines of code to use that image to use that neural network. So this is the thing. We have an application-specific plugin that provides interface that is required for your application. So it's a very clean approach that is easy to use by the end users. Oh yeah, sorry. So okay, this is what we need.
So that then defines the only way of using distribute?
It can be produced also from the Java code.
Okay.
You have neural network.save method, right, which saves the current instance of the yes. So another typical application that I will show. How much time do we have? Okay. So, is a stock market prediction. Well, I must say that this is not a production-ready support, but we have some basic support. We show how it can be done, and it's just a matter of playing with it a bit so to make it work. Again, we are creating the Neuroph project, right? Okay, and we start this wizard for stock prediction. So before I get started with it, I will show you how we are going to explain a bit how we're going to do it. So we have this. Is this one? No. Okay, this is the one. This is the file that contains the price of the chicken, right, on the market. So we want to predict whether the price of the chicken is going to go up or down, and to decide whether we are going to sell or buy chicken. Yeah, this is contributed by one of our community members. This is a very basic support for stock prediction. It is based on time series prediction, and it is using the windowing technique. I guess that you are quite familiar, know what I'm talking about, which basically means that you are using that data about the chicken price to create a data set to predict, and you, for example, you're using a price for the 3 days to predict price for the 4th day. And you go through the whole data set and use first 3 days as an input and the 4th day as out. Then use next 3 days as an input and 4th day as an out. So this is how you do it. Again, we have a wizard to do this. Start stock market prediction wizard. And you choose a file that contains chicken price data. Then you say specify delimiter in that file. It will be a white space. let's say, name for the data set. It will be chickens data. And when you import data, it has to be normalized. It has to be scaled to the interval between 0 and 1 in order to, so it can be used by neural network. So since our chicken data is between 0 and 100, the decimal scale normalization factor will be 100, so we make sure that they are all less than 1. Next, we set the parameters that we use for time series prediction. The first one is memory. It means how many days we are looking behind. So we can say we will look 3 days or 4 days or 5 days or how much we want. Let's say we will be looking for 4 days. Next parameter is frequency, which is basically a sampling rate. It means are we going to look at each day, or we are going to look at every second day or every third day. So these are parameters which are very tricky to adjust, and the prediction depends on them very much. And steps ahead is a parameter that decides how many days ahead we are trying to predict. Usually we use 1 because using more steps ahead is error prone. Then we set the neural network parameters. Okay, put, for example, 9 neurons and hit finish. Again, we get the neural network, we get the training data, and we hit train. But since this, we have to lower the error, since this data is okay. So network is training. You can see it nice in this graph because it is too low. It is very small error because the data is normalized. You see the network is going down, but it will probably take some time. You can see it is 1.2 and it should be at least 4. So since we don't have much time to wait until this network is trained, I'll just show you how do you use predictions. So we will assume that it has been trained. So you select the neural network. This is the window for testing network. Normalization scale. We'll say the chicken price, some input. Let's see, this is the data used. Let's say I enter prices for the chicken for the 4 days, and I'm trying to predict, see? And it says it will be 86, and actually it should be 81. But we have not trained, we have not finished training. What's important? That the price grows, right? So the prediction... No, not really. It is. There are two types of time series prediction. One when you're trying to predict exact value, and the other type when you're just trying to predict a trend. Is it going to grow or is it going to fall? So if it grows, then keep your chickens and wait to sell it. When the network predicts that the price is going to fall, right? That was it. And last thing that I promised at the abstract session is that something that I'm planning to do, and to be honest, I haven't made some experiments with it, but I'm preparing. And well, the idea is to use neural networks to approximate the behavior of a Java application, of the Java virtual machine, of the garbage collector, and then to try to optimize the parameters. And so you can optimize, for example, size of the heap, or all those parameters that determine the behavior of garbage collector. There are, I know, if you take a look at the list, there are dozens of them, so you can use. And it is very hard to tweak them all, and it is very nonlinear behavior. And there is no way someone can give you rules for doing it. So people have actually done this, and this is, I borrowed these slides from the folks we have listed here, from Georgia Tech company and from Intel, and they have been using for tuning the workload for the application. And this is, see this problem, these red dots look familiar to you, right? But not, it's not two-dimensional space, it's a three-dimensional space, which is perfectly right and can be used on Neuroph right away. And we have different layers, like hardware operating system setting, Java virtual machine, Java application server, and your application. So if you want to get the idea what is going on, how your application behaves on a different workload, or how it behaves with the different settings for the JVM, you can get the sample about your application, how it performs, determine the configuration parameters for input, and the values that you're going to check for an output. So what they have done, they took a thread pool size and JVM heap size and checked the response time of the application, right? And there is a way you can validate the model, so you can make sure that it behaves well. So I will try to do it, and if any one of you do it before me, please let me know. So this is what configuration parameters they have been using, thread count, assigned to different. So I think you have seen how it looks, that is platform application, and Gertjan is here today to tell you, okay, what are the benefits for if you are creating some application, desktop application, you have some framework you want to improve the UI. Here are some ideas.
Yeah, just very quickly, the framework underneath this application is called the NetBeans platform, and it enables Zoran and the team working on this project to immediately begin working on the domain level. They don't need to worry about the architecture, they don't need to worry about the window system, they don't need to worry about the action system, the menu bar, the toolbar. All of those are provided out of the box by the NetBeans platform. It's an open source and free application framework that you can use as the basis of your own software. You might recognize this partially if you've used NetBeans IDE, but also Gephi, also the NATO system that has won the Duke's Choice Award. This year, the AgroSense farm management system that has also won a Duke's Choice Award, and a refugee management system used by the UNHCR, which has also won a Duke's Choice Award. So there's a lot of development going on top of this framework. And enabling this kind of application to be developed much faster than it would otherwise have done. I've got a whole bunch of cheat sheets and introductory cards about this framework right here. So if anyone's interested, you can stop by here afterwards and pick it up. And it provides all the information, all the links to tutorials and books and everything that you might need.
Okay, thank you, Gertjan. Thank you everyone for coming.